Hello students! So this video here is, or this lesson here is about solving radical equations. Guys, just a brief reminder, we have talked a little bit about radicals in some of our previous lessons where we were discussing solving quadratic equations. And again, we kind of broke down some of the different parts of radicals. We're not going to do that again here, but again, I mentioned that because, again, guys, remember there are different types of radicals, but the type of radical that we're going to focus on, or the type of radical equation that we're going to focus on in this lesson is square roots. So we're going to look at solving square root equations. And again, a square root is a particular type of radical. Okay, so we're going to look at solving square root equations. And guys, we're going to go ahead on and jump into some examples because the easiest way to explain this concept to you with solving radical equations is to show you with examples. And of course, we'll break down each step that we're doing. All right, let's go ahead on and get started. Okay, so let's look at this example here. So this says solve the negative square root of x equals -7. Guys, it's important for you to know that if you have an equation that looks like this, a radical equation that looks like this, and what I mean by this, or looks like this, I mean when you have a radical equation where there is a radical only on one side of the equation. And so here, guys, you see that there's a radical only on one side of the equation. If that happens, guys, then the first thing that you need to make sure you do is to make sure that radical is isolated. Okay? What do we mean when we say make sure that radical is isolated? We mean make sure that radical is completely by itself. In other words, guys, make sure that you only have that radical and whatever is inside or up under that radical. Guys, if you have anything that is outside of that radical, if you have any numbers that are being multiplied on the outside like this times something, and you may not have the multiplication dot, but if you got anything that's multiplied on the outside, the radical is not isolated. And if you got anything that's added or subtracted on the outside, then your radical is not isolated. Okay? So again, guys, if you got anything that's multiplied on the outside, your radical is not isolated. If you got anything that's added or subtracted on the outside, your radical is not isolated. So again, guys, if you want to make sure that radical is isolated, in this particular example, the radical is not isolated, okay? Why is it not isolated? Because there's a negative on the outside, and technically there's a negative number that's multiplied on the outside, and you guys should be able to tell me what that negative number is. Yeah, it's understood that negative number is a -1. So again, guys, the first thing we want to make sure we do, since there is only one radical, since there's a radical only on one side of the equation, is make sure that we have that radical isolated by itself on one side of the equation. Okay, so guys, let's go ahead on and do that. Again, guys, as I mentioned, what's keeping this radical on the left side of the equation from being completely isolated is that -1 that's being multiplied on the outside of it. That's the only thing right now that's keeping that radical from being isolated by itself on one side of the equation. And so, guys, if we want to isolate that radical, you should know what inverse operation we're doing. Again, if the -1 is being multiplied times this radical, the inverse operation here is for us to divide by -1. Okay, that's a little sloppy, but it'll have to work, and that's probably even sloppier. That'll work. All right, so we got to divide by -1, which cancels that out, of course. And then now we've got this radical by itself. -7 divided by -1 is 7. Okay, guys, are we done? No, of course not. Because if we're solving for x, we need for x to be completely by itself. So the first step was making sure, for this particular type of example, the first step here was making sure that radical was completely isolated. So now that it is completely isolated, guys, now what we need to do is we need to actually get this radical to cancel out. So guys, how do we get a radical in a radical equation to cancel out? We use the inverse operation. So guys, what we need to do here is we need to square. We need to square both sides of the equations. Square both sides of the equation. Okay, guys, when we square both sides of the equation, first of all, we're squaring both sides so that we can keep the equation balanced. But when we square this thing, guys, because a square and a square root are inverse operations, that square and the square root will cancel each other out. And that's what we want to happen, guys, because guys, we technically will not will not have x all the way by itself unless we can get this square root to cancel. So again, we get that square root to cancel by using the inverse of that square root, which is us squaring both sides. In other words, we need to raise both sides to the power of 2. All right. So let's go ahead on and do that. Let's go ahead on and square both sides of the equation. Let's raise both sides of the equation to the power of 2. Okay. Again, folks, as I mentioned, because this square and this square root, when they happen together like this, and when those two operations are performed together, like what you see on the left side of this equation now, because they are inverse operations, guys, they will cancel each other out, as you expect inverse operations to do. So that square root and the square cancel each other out. And that's exactly what we need that's exactly what we needed to happen in order for us to get x, to even begin to get x by itself. Okay, so now that those two inverse operations have canceled each other out on the left side of the equation, now we're left with x, only x, and it's equal to 7 squared. And guys, we should know that 7 squared is what? 49, right? Awesome. Yeah, okay. Trying to write that where it doesn't look too jumbled up, but it's all good. All right, so again, guys, x equals 49. And folks, again, I'm just going to make mention here that you should, especially when you're doing these radical equations, but really with any type of equations that you're solving, please make sure that you go back in and plug in these answers that you get to make sure, plug it into the original equation to make sure that it works. Okay, I'm not going to do that with this first equation. Again, I know that this works because the square root of 49 is actually 7, and then when you multiply that times -1, you get -7. Okay, but anyway, I'm not going to do that I'm not going to actually show that with each of these examples. But again, guys, we should make sure that we always plug in and check to make sure that we have the correct answers by plugging them back in to our original equations. I'm going to show you with the very, very last example that we do, and I'm going to show you with only the last example to make a specific point. All right, we're getting ready to look at the next example. And again, folks, the solution for this particular equation in this example was 49. The only value of x that will actually work when we plug it in is the only value that will work when we plug it in for x. So x equals 49. Okay. And again, please make sure that we plug in those answers after we get finished solving to make sure that it's correct. All right, next example. Okay, so this next example here, we've got 2 times the square root of 3x minus 6, and then we've got the plus 5 equals 11. So guys, this example is actually for the most part for the most part, very, very similar to example 1, where again, we've only got a radical on one side of the equation. Okay, so we've got a radical only on one side of the equation. So pretty much we're going to follow the same steps that we did in this last one, but there's a little bit more involved with isolating this radical for this example. So again, the first thing that we want to make sure that we do, because it is very similar to the first example, is we want to try to isolate that radical. Again, guys, in order for this particular radical, I'm going to erase this after I write it. In order for this particular radical to be isolated, we would need to have that radical and only the stuff that is written inside the radical. If we've still got the stuff that's outside the radical, like the *2 and the +5, then the radical is not isolated. But again, guys, in order for it to be isolated, it needs to only be written where you only have the stuff inside of that radical. Okay, so we need to use inverse operations to isolate that radical. Get it by itself on one side of the equation. And again, I'm getting ready to erase this. Goodbye. All right, so guys, let's go ahead on and do that. Let's work this out to get that radical isolated by itself on one side of the equation. Let's use some inverse operations to remove that +5 that's on the outside and to remove that *2 that's on the outside of this radical. All right, so guys, I suggest using the inverse operation to get rid of or to eliminate or cancel out this +5 first. And so the inverse operation there would be subtracting 5 on both sides, -5 minus 5. When we do that, this cancels the 5s out. We still got the 2 times the square root of 3x minus 6 on the left side of the equation. On the right side of the equation, we've got 11 minus 5, which is 6. All right, and then the only other thing left to do to isolate that radical is to use the inverse operation to cancel out that 2. So again, the operation that's going on right now between the 2 and that radical is multiplication. The inverse operation that we need to use is dividing. So we need to divide by 2. Okay. A little bit better. Not really, but it'll work for now. Yeah. Better. Divide by 2. Alright, so we've got the square root of 3x minus 6. Okay, that looks so much better with that radical completely by itself, isolated, by its lonesome. Alright, so again, folks, now that we've got the radical, that radical by itself, now is where we can go ahead on, and where we should go ahead on and square both sides of the equation. Guys, remember that again, when we square both sides of the equation here, or at least when we square the left side of the equation, that square and the square root are going to cancel each other out, because a square as an operation is the inverse operation of taking the square root of something. So again, when we square both sides, raise both sides to the power of 2, the square and the square root are going to cancel each other out, just like they did in the first example. Alright, so let's go ahead on and do that. Let's go ahead on and square both sides of our equation. Let's raise both sides of the equation to the power of 2. And when we do that on the left side, the inverse operations of squaring and that taking the square root, those two operations, inverse operations there, are going to cancel each other out. The square root there and the square, we're going to cancel each other out, and we'll just be left with this part here, the 3x minus 6 on the left side of the equation. So we've got 3x minus 6 equals 3 squared, and okay folks, 3 squared is 9, correct? Yeah, absolutely. So 3x minus 6 equals 9, because again, 3 squared equals 9. Okay. Alright, so again, now folks, now that we've actually gotten that radical to cancel out. And again, the only way that we got that radical to cancel out, and that was the only way for us to really solve this, the only way for us to get that radical to cancel out was for us to square both sides of the equation. All right, so now that we've done that, the only thing left to do now is to finish solving for the variable. So again, let's solve for that variable. Let's go ahead on and do that. So we'd have to add 6 to both sides, which would give us 15. Hate to make that smaller. Hope you guys got very good eyes. All right, so if we add 6 to both sides, I will try to blow it up or zoom back in a little bit later. All right, we've got 3x equals 15. And then, of course, the last step here to be divide by 3 on both sides. And 15 divided by 3 gives us 5. So x equals 5, and that is our solution here for this particular problem, for this example here. All right. Yeah. We zoom back in for those who might not have been able to see that. All right. So again, guys, that was example 2, and that was very similar to what example 1 was like. But again, guys, we're gonna go ahead on and look at another example that's slightly different. Again, folks, I'm not showing you examples that are exactly alike because there would be really no point. It would be a waste of your time and my time to show you examples that are exactly alike and not show you a variety of different types of problems like you will see on your practice that you'll do. Again, my students enrolled in my classes at our school. All right, so another example and probably 2 more examples here, and then we'll call it quits here. Okay, so guys, this here is the next example. Again, this one looks different, and that's on purpose. Again, guys, we don't want to show you just the same type of problems. But anyway, the first 2 examples were equations that had a radical only on one side of the equation. So again, notice how this equation in example 3 doesn't just have a radical on only one side of the equation, but it's got a radical on both sides of the equations, a radical on each side of the equation. And so when that is the case, if you have an equation where there's a radical on each side of the equation, then you would usually begin by squaring both sides of the equation. So and really, guys, it really would not matter in this particular case where there's a radical on each side of the equation. It really would not matter if the radicals are isolated. But again, you would usually begin, folks, in an example like this where you have radical on both sides on each side of the equation. You usually begin by squaring both sides of the equation. So, folks, when we square both sides of the equation, we would still expect for the inverse operations of squaring and square rooting. We would still expect for those inverse operations to cancel each other out. Okay, so let's go ahead on and do that. Let's go ahead on and square both sides, and we'll see when we do that those inverse operations will cancel each other out. All right, so we're going to square this side, square, and we're going to square this side. Raise both sides to the power of 2. All right, so here we've got the square root of 23 minus x, and on the right side we had the square root of 9x plus 43. Again, when we do that, those inverse operations, the square root and the square cancel each other out. And in this particular example, for this type of equation where we have radicals on both sides, we do expect for those inverse operations to cancel out on both sides of the equation. All right, so on the left side, we'll be left with 23 minus x. On the right side of the equation, we'll be left with 9x plus 43. And again, from here, guys, we'll just solve for that variable. Now that we've got those inverse operations that canceled each other out. All right, so remember, folks, we're solving equations like this with variables on both sides. We want to make sure that we get all of our variables together on one side of the equation. And so I'm going to add x to both sides, and for this particular, me doing it this way, I'm going to have all my x's together on the right side of the equation. All right, and remember, guys, we want to get all the variables together on one side of the equation, and we want to get the constant terms on the other side of the equation, away from your terms with variables. And so that means that we need to move the 43 over to the left side of the equation. So let's use the inverse operation, subtract 43 from both sides. 23 minus 43 gives us negative 20. Negative 20 equals, okay, I'm going to have to move that apparently. Negative 20 equals 10x. Okay, and then when we divide by 10, we end up getting here negative 20 divided by 10, so x equals negative 2. And again, folks, just as a little reminder, please make sure that you go ahead on after you solve. Please make sure that you plug in that answer that you got. Plug it into the original equation to make sure that it actually satisfies that equation. Make sure that when you plug in that value that you've solved for, make sure that it actually makes the equation true. Again, guys, that is example 3, and I'm only going to show you one more example that is different from these other examples that we've done as well. And in that example, I am actually going to actually show where we are plugging in the solution, plugging in our solution back into the equation to make sure that it is correct. All right, so folks, here we've got example 4. This example is closer to closer to example 1 and 2 than it is to example 3. But again, even though it looks more like example 1 and 2, it is still different from examples 1 and 2 as well. And you'll see that when we actually start or while we're working it out, you'll see how this one is different from example 1 and example 2. All right, so guys, again, this one is similar to example 1 and example 2 because there's a radical only on one side of the equation here. There's a radical only on one side of the equation, and we need to go ahead on and make sure that radical is isolated. Okay, so let's go ahead on and do that. Let's go ahead on and get this radical by itself. And so, in order for us to do that, let me just rewrite this again. X minus 3, square root of x minus 3 plus 8 equals x plus 3, okay? All right, so in order for us to get that radical by itself, right now the only thing that's keeping that radical from being completely by itself is this plus 8 that's happening on the outside of that radical. So guys, the only way for us to cancel out this plus 8 is to subtract 8 on both sides. So let's subtract 8 on both sides. When we do that, it cancels out those 8s. We're just left with we're left with the square root of x minus 3 on the left side of the equation. On the right side of the equation, we've got x minus 5. Because again, 3 minus 8 gives us negative 5. Wish that was a little bit neater than that, but it's all good. Yeah, a little bit better. Alrighty. So now we do have that radical isolated. And so guys, from here, again, it's pretty much sort of the same way pretty much as what we did in example 1 and 2. But again, even though guys we're going to square both sides of the equations, you're going to see here that when we square the right side of this equation here, this is going to wind up being a quadratic equation when we square the right side of this equation. And again, guys, we need to square this equation and both sides of the equations so that we can get this radical to cancel out. And so again, we're squaring both sides again, folks, because we need to use the inverse operation of squaring in order to get that radical to cancel out. But again, folks, you will see when we square that this is going to wind up being a quadratic equation, and that's how this example is different from example 1 and 2. All right, so let's go ahead and do that. Let's go ahead and square both sides of the equation. Square the left side, square the right side. All right, when we square the left side, we're squaring the square root of x minus 3. And on the right side, we're squaring x minus 5. All right, so again, folks, we know that when we do those two operations together, that square root with the square, and we don't really have time to talk about how the fact that is a composition of functions. But anyway, when we do those two functions together like that, because they're inverse operations, they will cancel each other out. And again, on the left side here, we've got left x minus 3. On the right side of the equation, we've got left x minus 5 squared. Now, guys, on this right side of the equation, we've got a perfect square binomial here. Now, folks, if we want to solve this quadratic equation, and again, you should recognize that it's quadratic because, again, literally, you see that this thing here is raised to the power of 2, and that's a perfect square binomial. But anyway, if we want to solve this equation, you're going to need to simplify this perfect square binomial. You're going to need to expand it. What do we mean? We mean that we need to actually write it. We need to actually write this out. Remember, guys, that when you've got something squared, that is the same thing as this thing multiplied by itself. Remember that this is repeated multiplication. Alright, so again, folks, what that means is, since that's repeated multiplication, we've got x minus 5 multiplied by itself, right? And so we need to actually multiply that out and simplify it. And then we can work on actually solving this quadratic equation, because it is a quadratic equation. Alright, so again, we write that out as repeated multiplication, because that's technically what it is. And folks, remember that we need to either use the FOIL method here, because we're multiplying two binomials, or you can use the box method or extended distribution. But again, folks, one way or another, you need to multiply this out and then simplify afterwards, right? Alrighty, so again, folks, x minus 5 times x minus 5. I really don't have to do that. I know that this is going to be x squared minus 10x plus 25, but for your benefit, I'll write this out just so you can see this here. Minus 5x, minus 5x. Oh, why am I writing so big? Minus 5x, there we go, minus 5x. And this is plus 25 when we multiply that out. Again, folks, we've done lessons on on doing operations with polynomials, and so we should know how to multiply two polynomials. And in this case, this is multiplying two binomials, but again, same concept as multiplying two polynomials. All right, so again, we've got those terms, and we need to simplify or combine those like terms. The two like terms there are negative 5x and negative 5x. If we combine those two like terms, that's going to give us negative 10x. And then we just bring everything else down. Okay. Remember, folks, since we are solving this quadratic equation, probably the easiest way for us to solve this quadratic equation would be for us to factor it. But again, guys, if factoring is not your cup of tea, if that is not your forte, your strength, your strong suit, then you may want to use the quadratic formula. But again, folks, remember that whether you're using solving by factoring or solving using the quadratic formula, and again, folks, these are not the only two methods that we could use to solve the quadratic. But again, these are the two probably easiest for you guys, probably the easiest for you guys to use, and that's why I'm mentioning these. So again, in order for you to use one of those two methods, solving by factoring or solving using the quadratic formula, you would need to get the equation set equal to zero on one side, and you would need to make sure that the other side of the equation was in standard form for a quadratic equation. Alright, so again, we need to get one side of the equation set equal to 0, and the other side of the equation set in standard form. Alright, so I'm going to go ahead on in and start getting all of my terms on the same side of the equation, so that I'll have 0 left on one side. So if I subtract x here on the left side of the equation, wow, what was that? What did they just do? Yeah, okay, that looks better. If I subtract x on both sides of the equation, it cancels out on the left side. You got minus 3 or negative 3 equals x squared. Negative 10x minus x. That's negative 10x plus negative 1x. That's negative 11x. Bring down the plus 25. And then if I add 3 to both sides, alright, that cancels out. Again, folks, if we're using the quadratic formula or trying to solve by factoring, we want one side of the equation to be equal to 0, and we want the other side of the equation to be written in standard form. Alright, so here, x squared minus 11x, when we combine the 25 and the 3, that is plus 28. Again, folks, I'm not going to show both methods of solving by factoring and using the quadratic formula. If you want a refresher on using the quadratic formula, I'm going to write out again the quadratic formula. Here, x equals negative b plus or minus the square root of b squared minus 4ac. If you want a refresher on how to use the quadratic formula, for those who may not remember, you can look that up on your personal time, or go back and look at some of the previous videos or lessons that we've gone over with using solving quadratic equations using the quadratic formula. Again, you can subscribe to my YouTube channel and look at that, or you can look that up on your own personal time as a reminder. Because again, it shouldn't be new, because we've gone through this lesson already on solving quadratic equations. Alright, so again, I'm going to solve this by factoring. Again, I've got the quadratic formula written over here, but I'm going to solve this by factoring. Okay? I've just got the quadratic formula written over here to remind you of what the quadratic formula is. Alright, so we're going to solve this. I'm going to solve it by factoring. You can solve it whatever way that you remember how to do, but I'm going to solve this the easiest way here. So we need to find two factors of C. So two factors of the constant term, and that's two factors of 28, that will add to give us that middle term, that will add to give us that linear term, negative, or that linear coefficient, the coefficient to the linear term. So two factors of 28 that add to give us negative 11. So two numbers that multiply to give us positive 28, but add to give us negative 11. Those two numbers that multiply to give us positive 28, but add to give us negative 11 are negative 4 and negative 7. And so guys, if you remember, the way we write out these factors when we're solving by factoring is we write it out as x minus 4 and x minus 7. Again, folks, oops, I didn't mean to write 4 twice. X minus 7. Again, folks, remember that we have to use the zero product property where we set each of those factors. We set each factor equal to 0. So here we've got x minus 4 equals 0 and x minus 7 equals 0. And when we solve each equation, the equation on the left side, we add 4 to both sides. I'm not gonna show adding 4 to both sides. If you can't solve a single one-step equation at this stage, I'm not saying that you can't learn how to do it, but we don't have time to write that out at this moment. X equals 4 there. Again, here we use the inverse operation. The inverse operation here, where we see this subtracting 7, the inverse operation will be adding 7 here. Alright, and again, I'm not writing that out. But again, there we go. If we add 7 on both sides, we would have x equals 7. Alrighty. So guys, remember, I told you that you should always check to see whether or not your solutions that you found will actually satisfy your original equation. So again, guys, we're going to actually do that here, and I'm going to show us doing that here in this example, and then we will call it quits. I promise. Okay, so let's go ahead on and do that. Let's plug in both of these answers into our original equation. Again, guys, it's always a good habit to make sure, no matter what type of equations you're solving, no matter whether it's systems of equations, whether it's linear equations, quadratic equations, any type, radical equations, those just happen to be the only type of equations we've talked about solving so far that I recall. But again, when you're solving any type of equations, please make sure that once you have finished finding your solutions, please make sure that you plug them back in to make sure that they are correct. All right, so let's plug these into the original equation. The original equation here was the square root of the square root of x minus 3. What was that? Plus 8 equals x plus 3. All right, I'm going to write this out twice because we've got to substitute or we've got to plug in not only just one of those x values, but both of them to make sure that they both work. That was the square root of x minus 3 plus 8 equals x plus 3. Alright, so let's plug in the 7 here, and guys, everywhere where you see x, that's where you're going to plug it in. So don't just plug it in for only one spot where you see x. Plug it in everywhere you see x. So that's 7 minus 3, and it is the square root of that. Okay, we still got the 8 here plus 8, and here you got 7 plus 3 there. Okay, well, clearly 7 plus 3 on the right side of the equation here is 10. On the inside, oops, give me a sec. On the inside of of that radical, the 7 minus 3 is 4, right? All right, and then guys, when we think of the square root of 4, the square root of 4 is what? 2, right? The square root of 4 is 2, so that is 2 plus 8 equals 10. The question is that true? Why, yes it is. So, since that's true, guess what? Okay, x equals 7 satisfies our original equation. We know for sure that's a viable solution. Okay, so x equals 7 is definitely a viable solution. It works. In other words, it's a viable solution if it works when you plug it back into the equation. I'm not apologizing for using big words like viable, and it's really not even a big word. It's only 6 letters. But anyway, we can refer to it as a viable solution if it works, when you plug it back in. In other words, if it makes your equation true when you plug it back into it. All right, so x equals 7 is a viable solution. Yes. That works. It satisfies the equation. It works. Check. Checkmate. All right. Let's do the same thing with the 4, folks. We need to plug in the 4 and make sure that works when we plug that in. Oops. Aha. And we've got the square root of that 4 minus 3. If we're plugging in 4 everywhere we see x. Okay. And that equals 4 plus 3. Alright, so guys, on the right side of the equation, now that we've plugged in 4, 4 plus 3 is 7. Okay, and folks, okay, let me just rewrite that for now. I hope that doesn't look too sloppy, too crowded. Square root of 4 minus 3 plus 8. Okay. Alright, so next guys, if we simplify what's up under this radical, the 4 minus 3, that part that's up under the radical, 4 minus 3 is 1. So guys, this is really the square root of 1. Alright, so that's the square root of 1, technically. You still got the plus 8 here, and that's there. Okay guys, the square root of 1. What's the square root of 1? Square root of 1 is 1, right? Because 1 is the only number that you can multiply by itself to get 1. Alright, anyway, the square root of 1 is 1. And so we still got the plus 8, and we got the equal 7. So the question is this equation true when we plug in 4? Well, 1 plus 8 is 9, right? Oh snap, y'all. What's up with that? What up with that? Huh? 9 ain't equal to 7. 9 is definitely not equal to 7. Okay, folks. Alright, we have a failure here. Alright, so since we have plugged in that 4, and guys, this is why we need to check our answers. Regardless, we need to check our answers anytime we're solving an equation. Plug your answers back into the original equation and check. You should always do that. Always, always. Okay? Now guys, for these types of equations, radical equations, when you get a solution like here, we definitely got 4 as a solution. There's no way to work around that. We definitely got 4 as a solution. But guys, when you get a solution that winds up not working, that winds up not satisfying your equation. We call that type of solution, yes, it is still a solution, even though it doesn't work. We call that type of solution extraneous, an extraneous solution. That extraneous solution is not one that we can actually use. It's not one that's actually viable. It's not usable. It does not satisfy the equation. But again, let me write that a little bit neater, and let me spell it out as I'm writing it. Let me hook you on phonics. Reading rainbow. All right, EXTRANEOUS. We call that an extraneous solution. When we have a solution that does not work, it is not viable, it does not satisfy the equation when we plug it back in. X equals 4 is an extraneous solution because it does not satisfy your equation. It does not work. We cannot use it. Okay, that pretty much does it, guys. Again, we've gone over 4 different types of examples where we are solving radical equations. Again, folks, please make sure that you always check your answers after you finish solving. And the reason why is because, folks, you may end up getting an answer that is not usable, that's not viable, not usable. Okay? Not viable, not usable. Okay? And that type of solution that's not usable, that does not satisfy the equation, is called an extraneous solution. Let's see if that will actually put this in the box. Probably not. I'm so surprised that it did. All right, not viable, again, or in other words, guys, it's not usable. That's it, folks. I'm done. We're done here with this video. That's all. I do hope that this has been helpful to you. Yeah, that's all. Okay. Alrighty. That's it. That's everything. I do hope that this has been helpful to you. Goodbye.